Hello. So here we are again to solve one of the questions you sent me. We have this video for question number 3 in, I believe it's 2023 June, paper 2. So yeah, this question is about an oscilloscope. Now, the first thing I believe that's gonna come to your head when you look at this question is like, man, I don't know what is oscilloscope. I can't solve a problem that has to do with it, right? No, I'm gonna show you that you don't have to know everything about oscilloscope in order to solve this question. Rather, you don't even know what is the purpose of using this device, but it's better if you know. So oscilloscope is just it's a device to test and display voltage signals and kind of represent them as waves. So it is a voltage that is shown to us as waves so that we can study the characteristics and so on of the signals that we are receiving. That's what you have to know about oscilloscope, but this question has nothing to do with this. I'm going to show you that even though that you don't know about it, you can solve it, okay? All you have to do to answer this question, 3 things you have to know. Number 1, that electrons have negative charge, and negative charge or similar charge, they're going to repel each other. And you have to know a little bit about kinetic energy. That's all. Now let's try to solve it. Here, starting with A, it says like the grid is connected to the, you have to read the question, but I'm kind of too lazy to do so, okay? But okay, sorry, let's do it. The diagram shows the inside of an oscilloscope. Electrons leave the electron supply, which is this part here. They're gonna leave it and accelerate towards the screen. This is where they go. This is the stream of electrons. They go this way. The stream of electrons hits the screen. So they're gonna go until this screen here where it hit it, and they're gonna stop. And we're gonna see the signal, by the way. So the grid is connected to the positive terminal of a high voltage power supply. This is the grid, and this is where it is connected to the positive part of whatever cell or any kind of power supply. The first question is, explain in terms of movement of particles how the grid has become positively charged. So that's an easy question because it only has to do with the charges and whatever you know about them. Now, we know that here this is connected to the positive part, right? So, and we know that the grid, it has positive and negative charge. Positive and negative charge. This is because of the atoms. The atoms each atom has positive and negative charges, right? So the negative charges in the atom, it is what? It is the electrons on the orbits around the nucleus. So these electrons, especially the last ones, they're kind of like a little bit more free than the rest. So whenever they get even a little bit of energy, they can free themselves and go to the positive part here. So these electrons here, they will be attracted to the positive part of the power supply. And then what's gonna happen? They're gonna leave the grid. So what will happen when this is a grid again, all of the electrons or the negative, not all, part of the electrons are going to leave this grid. We will end up having more positive charge than negative charge because a lot of the negative charged with electrons, they left the grid and went to the power supply here. They went here. Yes, minus. So we will end up having a grid full of positive charge, more of positive charge than the negative charge, since the electrons, some of the electrons left the grid in order to be with the power supply, since opposite. charges, they will attract each other. So this one has 2 points. The first one, you will have to talk about electrons. Since they are negatively charged, they will be attracted to the positive part of the power supply. So they will transfer from the grid to the positive part of the supply. This is number one. Number two, you're going to talk about the grid. Now the grid has been, the electrons, they left the grid, and so the grid will end up being positively charged since it lost some of its electrons. I hope it's clear. Let's go to the next one, which is state the formula linking kinetic energy, mass, and speed. And I believe you know this. We have seen this one a lot of times. Now, since they asked about the formula here, next question, you guessed it, they will ask you to apply it. Calculate the speed of, calculate the speed, so they're asking for velocity or the speed of the electron when it has 1.3 times 10 to the power minus 15 joule of kinetic energy. So we have the kinetic energy as 1.3 times 10. Okay, and they also give us the mass. It's right here. So the mass is 9 times 10 to the power 31 kilogram. First of all, we have to make sure that all the units are correct, and so now we have just to apply it on here. And since we have the kinetic energy, we have it, it's given to us here, and we have the mass, and we don't know about the velocity, so pretty much let's start working on it from here. V squared is equal to, it's gonna be 2 times kinetic energy over the mass, right? And don't forget the square here. So if we want to find only the velocity, we will have to take the square root of this. And now all you have to do is substitute it correctly. Do I have a space for it? Let's try to do it here. So 2 times kinetic energy is, 1.3 times 10 to the power 15. This is over the mass, which is 9.1 times 10 to the power minus 31. And you use your calculator to find the answer. I don't know. Just find the answer. And you're gonna get 3 marks. Let me see the schema, by the way. Why do I have to solve it here? It is 5.345 something times 10 to the power 7 meter per second. I think it is not that difficult, right? So let's go to the B1. The stream of electrons spreads out as it travels towards the screen. Let me show you this in the graph after I clean it a little bit. So what they're saying is that, you see here, it is a little bit narrow here, right? But here it is kind of more spread. Here it is kind of narrow, here it is a little bit wider. Why? What did happen here? What happened here to cause it to spread a little bit? Why it is narrow here, why here it is a little bit more spread out. So as I mentioned at the beginning of this question, all you have to think about is that the charges of electrons, they are negative. So when you have a bunch of negatively charged particles, what's going to happen between them? They're going to repel each other, right? And that's why, since they are like the same negative charge, then they will repel each other. And this question has two marks, so 2 ideas you have to mention. Number one, that electrons, all of them, they are negatively charged, or they have the same charge which is negative. And then you have to say that since they have the same charge, they will repel. there is repulsive forces between the same or the similar charged particles. So yeah, this is for the B. For the C, the oscilloscope can cause the electrons to move in circle. I can explain to you this why, but I want to show you that even if you don't know that much about it, you still can solve this question. So please don't give up, even if you think that you have absolutely no idea about the device or whatever the situation or the example they're given in the exam, you still can solve anything regarding the physics behind it. So here, the oscilloscope can cause the electrons to move in a circle. This produces a circular pattern on the screen. Okay, so the question is, use the scale to determine the radius of the circle. Now, all of this just to ask one question. Show me the radius of the circle. Forget about physics. This is pure math and this is simple math. Now, this is a circle. I can tell that this is the radius. Am I wrong? No, I don't think so, because this part and this part, they're identical. So this is our radius. It is our circle is right in the center, lucky us. So I just want this part, which is the radius. And you can just find out by counting the squares. One, and this is another one, and this is a half square. So we know that our radius is equal to 2.5 squares, right? But I don't have something called squares as my units, as a unit here. I have to transfer it somehow. And we have the answer here. Each square is 1 centimeter. So we know that we have 2.5 squares and each square is 1 centimeter. So all you have to do is just times it with 1 centimeter and you will end up having 2.5 centimeters. And this is your radius, 2.5. Easy, right? So just have to see the circle, find where is your radius from the center to this point here, and here, from here to here, and you just have to count the squares connecting these 2 points, and then transfer it into centimeters, and it is given to us here for a reason. Now the next one is the time taken for the electrons to complete one orbit of the circle is 24 milliseconds. So the time is 24 milliseconds. So I'm gonna transfer to seconds, which means that times 10 to the power minus 3, or you can say like divided with 1000. Well, it's easier for me to do it that way, so let's go with it. Calculate the orbital speed. They're asking about the speed, and they also give us the speed, but I like to write it in samples. Like V is equal to 2 by R, the radius that we just found out, over the time. And they want speed, so we don't have to change to rearrange anything here. Everything it's like the way we want it to be, except for one thing, like the radius is 2.5 centimeters. We want it to be in meters, don't forget that. So you have to times it with what? Minus 2 meters. Now we're ready. So 2 times by times R, which is 2.5 times 10 to the power 2 minus 2, over the time, which is 24 times 10 to the power minus 3. And you just have your calculator beside you and you solve it. You'll end up having the orbital speed as 6.54 meter over second. And that's it for question number 3. I hope it is clear. If there is any problem regarding this one, you can ask me anytime. And I believe that you know now that you can solve it, even though that you don't know that much about oscilloscopes.